I welcome you all to the session of engine system and performance, and today we shall discuss about another two different types of control system, and those are memory based system and adaptive system. So, if we try to recall, in the last class or in our last class we have talked about control system and its classification. As such, we could define control theory, and any control system that will be used to run engine smoothly is reliant on the control theory. And we had seen that the control system can be divided into two different types. One is open loop type control system or open loop type control, and the second one is closed loop control or feedback control. And we had seen that the feedback system allows the system for rather the provision of feedback system or feedback loop allows the system to adjust for changing conditions, essentially to run the engine with optimum condition and ensuring reduced emission. So, in line with our discussion that we had in the previous class, we shall discuss today another two different types, that is memory based system or memory based control system and adaptive control system. As such, from the name itself you can understand memory based essentially that in a control system in electronic control unit or the engine management system will be having some table in which we shall in the table there will be a few stored data, and then whenever engine will experience any change condition, then that pertaining to that change condition engine will try to compare those data, or the engine will try to map those data to the lookup table. So, let us discuss about this particular type first, memory based control. So, if we write memory based control. So, what it does for a engine, or we have discussed that control systems are very much essential to ensure reduced emission, to ensure smooth and safety operation of engine, and to ensure that engine will run with optimum condition, right. So, let me write here a few words for this. Pertaining to this system stores optimum values of the control variables, optimum values of the control variables. What are those? Such as spark, timing, and fuel injection period or pulse width. Okay. So, pertaining to this type of control, the system will store data or store value of the control variables. What are those control variables? Spark timing and fuel injection period, or fuel injection pulse width, and this they will store data for a range of operating conditions. And the system will store data, or systems will store data in the form of table or map. So, I will be now marking these two words, or I will keep these two words under this circle. System stores optimum values of the control variables such as spark timing and fuel injection pulse width for a certain range of operating condition. It is not a case that only for a particular operating condition system will store the data. Essentially, to increase the flexibility of the system, we need to store data of these two control variables for a range of operating condition in the form of a table. I have marked, or I have kept these two words in the circle. So, what is optimum value? Optimum values are basically efficiencies. Optimum values are determined from the perspective of or from efficiency and emission consideration. Essentially, these two things are important for any engine. So, we need to ensure always whenever engines are modified, new systems are integrated, more complexities are brought. So, all these things are done essentially to improve the efficiency, and not only to improve the efficiency, certainly a good designer will design the engine, or researchers whenever they are doing some research on engine system, their target should be to increase efficiency, certainly at the cost of reduced emission level. So, it is not desirable to increase engine efficiency compromising or with a compromisation of emission level. So, we have to have these two things rather simultaneously. We also, we can increase efficiency with a simultaneous reduction in emission level. So, these optimum values that I have marked in the previous slide, optimum values include efficiency and emission consideration. And are derived from experimental tests. So, we need to perform tests and we need to take measurements or a test engine, and receiving or collecting or obtaining those optimum conditions, those will be derived or those will be obtained from experimental test. We shall store those. So, these are the optimum values. Now, again if we go back to the previous slide, and you can see that we have written over here again two words, that is optimum conditions. What does it mean? So, if we go back to, that means for a certain range of operating conditions. So, these operating conditions, if we go back to the next slides. So, these operating conditions so, for any operating conditions, we need to look for optimum values of the control variables. So, these operating conditions are always optimum operating conditions. And will be stored in ROM in a microprocessor control system. That means, we may have a certain range of operating condition, but for each operating point. So, for system for each operating point. That means, if we know our particular operating point, and if that operating points the control variables are the optimum control variables. So, for each operating points we need to figure out optimum operating conditions, and those optimum conditions will be stored in RM in a microprocessor control. So, now this is basically memory based control. So, it would be nice if we try to illustrate this type of system with the help of an example. So, with the help of an example, if we try to illustrate this system, that would be more clear to you all. So, now let us consider a particular example. So, example is, say, when engine load that is manifold pressure or speed, when engine load changes to a new condition, new value. Okay. So, this is an example. Say for example, say an engine is running, an engine is running at a speed with the help of certain amount of air fuel mixture. Certainly, we need to supply certain amount of air fuel mixture. So, receiving certain amount of air fuel mixture, if engine is operating or running, and if we assume that the engine running condition is the optimum condition. Now, when that engine load, certainly when engine is running at optimum condition, then engine load would be optimum, and that is the maximum efficiency we can expect from the engine. Now, if we increase the load or if we demand more load from the engine, then certainly engine operation or operating point should deviate from the optimum values. Now, when engine load changes to a new value, then few minutes back we said that if we go back to the previous slide, that these operating conditions are always optimum value, optimum operating conditions, and would be stored in ROM in a microprocessor control system for each operating point. And this, if we mark again, this is known as library of the control unit. This is known as library of the control unit, and those values, optimum values are stored in a table, in the form of a table, and that table is known as lookup table. So, when engine load changes to a new value, then certainly the control system will try to consult with the lookup table, and from the lookup table they will try to find out the condition, that at the present condition, the data corresponding to the present condition, and control unit or control system will try to adjust control variables like spark timing or fuel injection pulse width, so as to adjust engine load with the optimum value by tuning the spark timing, by tuning the fuel injection pulse width. So, let me tell you once again, if engine is running at the optimum conditions, then it is okay, but if the load, say for example, load demanded from the engine is more than the optimum value, certainly that would be manifested through some aspects, through some characteristics curve of the engine. Say then speed will reduce, manifold pressure will fall. So, all these things are will be there, and these are the indication of the load deviation from the optimum value. Now, that information will be sensed by the electronic control unit by control system. So, control system, what control system will do? Control system will consult with the lookup table and try to find out that what is the new condition, new operating condition, and pertaining to the new operating condition, engine issue will try to figure out what should be the control variables So, control variables need to be adjusted. So, if load increases, certainly we need to supply more amount of fuel, more amount of air. So, control system will now give some information to the control variables to adjust, to react to the the changed condition, right. So, now let us consider a lookup table. Say if we consider a table, and if we consider that is speed. So, 1000 rpm, 2000 rpm, 3000 rpm, 4000 rpm, 5000 rpm. Okay. So, in this lookup table, in the topmost row we have the speed values. So, these are the engine speed. So, these are engine speed. Now, if we look at the first column, here we are having, say for example, we have like this. So, 1, 2, 3, 4, 5 like this. So, this the first column is basically these are the load side. So, the first column is the load sides. So, increasing the number, this load side number, increasing load side number indicates increasing load. So, essentially these numbers indicate how far open the throttle valve is, right. So, if we keep the throttle valve opening for a, if the throttle valve is widely open, then certainly more amount of air fuel mixture will be supplied to the engine. So, engine load will be more. So, rather load that will produce by the engine will increase. That means, in the first column we have inserted a few numbers. These numbers are basically indicative measure of increasing load. So, if we traverse from the top row and if we go up to the bottom row, then we can see the number is increasing, load side number, and load side number increasing, load side number increases, that means engine load increases. Similarly, if we look at the first row, so what we can see that these are basically a speed side. So, this is speed side. Okay. So, you can see certainly it is increasing say is RPM. So, from 1000 RPM, 2000 RPM, 3000 RPM, 4000 RPM and 5000 RPM. In fact, we can have this lookup table, we can prepare based on the experimental data. So, essentially if we perform experiments using 10,000 RPM, we can have data. Now, so we do not have any, say this is 8, this is 8, 12, 12, 16, then we can have, say for example 14, 14, 18, 18, then 20, 24, 24, 24, 26, 26, 28, 28, then 28, 30, 30, then we can have 32, 32, 34, 34, 36. So, now again I have inserted a few numbers in the in this table. Now, question is we shall take this example, rather we have taken this example to illustrate the functionality of a memory based control system. As I told you that there are two engine variables or rather control variables, one is speed, another is the load. So, I have already explained that if we go from the first row up to the bottom row of the first column, then this load side number increases, that means engine load increases. Okay. Say for example, if engine is running at a given time at 2000 rpm and load produced by the engine corresponds to these three load side number. So, if we take this, so these two control variables corresponds to a particular operating condition of a engine, right. So, engine is running at 2000 rpm and load produced by the engine corresponds to 3 load side number. Then we can see this 18 is the value that is spark control, spark timing, that is 18. So, 18 degree, right. So, you have studied in your undergraduate course that spark advancement, spark plug should be on when piston is, if it is a SI engine, piston is, when piston is about to reach TDC, before reaching TDC spark plug should be on. So, the total sparking time, that is degree, that is also important. So, this is 18 degree. Now, if engine load changes to a new value, say for example, engine speed is, if I try to mark this value. So, if the new condition is 3000 rpm and still we need to have the corresponding load side number is 3, then at 3000 rpm if the load side number is 3, you can see certainly we have to again control the spark timing, then spark at timing should corresponds to this value, that is 24 degree. It might be a case that if the speed is 3000 rpm and load side number is 4, if the speed is 3000 rpm and the load side number is 4, then certainly we have to have this number for the spark timing, that is 26 degree. So, this information is stored in the memory based control, and whenever engine load changes, electronic control unit or engine management system consult with this lookup table and then immediately try to figure out what should be the spark timing or what should be the fuel injection pulse width, so as to adjust with the new condition, and engine can always produce maximum efficiency at a reduced emission level. So, this is all about memory based control system, but try to understand if a case is something like that, that engine is operating at 3000 rpm and producing load side corresponds to this number 4, and if the sudden speed changes to 3500 rpm, then that information is not given in this lookup table. So, electronic control unit is also programmed to interpolate between these two values. So, if it is 3500, certainly it is in between 3000 rpm and 4000 rpm. So, if the load side number is still 4, then ECU will be able to interpolate between these two values, that is 26 and 30, and to calculate what should be the spark timing for that particular engine. So, this is all about memory based control system, and the problem of this control system is that this memory based control system also has a few disadvantages. One is this points, this control system is unable to adjust to changes when there is a change from point to point in the engine components. Second thing is that whenever we are preparing this lookup table, we are performing some experiments and measurements are taken on a test of a given engine. Now, using this set of parameters, we cannot predict the performance of an engine which is not similar to the engine which was used to to measure data during experimentations. So, that is one thing. Second thing is, sometimes if the density of the fuel changes, then certainly then knock will appear, combustion knock will be there. That part also is not taken into account by this control system. And so, having all these basically these are the limitation of this memory based control system. Now, what about the adaptive control system? So, adaptive based control system. So, what I said that memory based control system, we have tried to illustrate the functionality of this particular type of system taking or with the help of an example, and we have also listed down or we have also discussed about a few disadvantages of this system. That is, this system is based on the measurement, the lookup table is prepared based on the measurement on a test engine, and then if the table is used to operate or control engine, control an engine which is not similar to the test engine, then I mean it will be very difficult. Second thing is that if there is gum deposit and change in fuel, then certainly this system will not be able to take into account that aspect. And as I said you that sometimes if fuel density changes, then combustion knock will be there, and ECU in that case ECU equipped with this memory based control will be in a position to or will start malfunctioning. So, all these things are there. So, what about adaptive control? Adaptive control, that let me tell you one thing, let me write exactly. So, in this type this system determines operating point for or from real time measurements of the engine variables and subsequently corrections of the lookup table, right. So, you can see the name itself, the adaptive control. So, the system will be adapt the change. As I said you, if we try to recall the example that we had considered to illustrate the functionality of memory based control, that when engine load changes. So, if the engine load changes, then electronic control unit will consult with the lookup table, but pertaining to this adaptive control system, that system will try to determine the operating condition from the real time measurement of the engine variables. That means, when engine is even running, then that will correct the lookup table. So, that is important. So, that means lookup table will be there. So, as I said you that if it is 2000 rpm and 3000 rpm, if engine load changes or if engine speed changes to 2500 rpm, then what should be the spark timing? System would be able to measure or determine that spark timing from the real time measurement from the engine itself. So, let us take an example. So, before going to that, that subsystem that have used adaptive control. So, there are many subsystems. So, let me write now subsystems that have used adaptive control or exhaust gas recirculation. Number 2, evaporative emission. Number 3, airflow control, and number 4 is air fuel ratio control. So, these 4 different subsystems, that is exhaust gas recirculation, in sometimes we call it EGR. So, this is also known as EGR. Exhaust gas recirculation system, evaporative emission system, airflow control and air fuel ratio control, these subsystems use adaptive control system. So, again let us take an example to illustrate this particular type of system. So, if we consider an engine and if we allow perturbation to the ignition timing, right, we know ignition timing, whether if it is kind of we need to ignite the fuel air mixture, right. So, if it is a spark ignition engine, we need to ignite the air fuel mixture by switching on the spark plug. So, if we allow perturbations or if we give some perturbation to the ignition timing, then the ignition time and torque. So, basically that if we try to recall, as such you have studied in internal combustion engine course, that if we delay the ignition, if we advance the ignition, the effective influence will be there on the torque that will be produced by the engine. So, if we give some perturbation to the ignition timing and then from the ignition timing torque curve is inferred from the engine load or engine speed. Okay. So, let me tell you once again, if we give some perturbation to the ignition timing and then of an engine, then from the perturbation, then ignition timing and torque curve is inferred from the response of the engine, okay, engine speed rather. Try to understand that in the former case, that is for the memory based control, we had lookup table, and when engine speed or engine load changes, control unit will consult with the lookup table and try to determine the operating condition, and corresponding to the new operating condition, lookup table from the lookup table control unit will give the optimum control variable, that is spark timing and fuel injection pulse width. But in this case that it is certainly it will be having lookup table, but the system will correct the lookup table value. So, that means system what this particular system will do, that operating conditions will be measured from the as I had written over here, that operating conditions will be measured from the real time experiments, right, and real time measurements from the engine variables, and subsequently that they will lookup table will be corrected, the data those will be there in the lookup table will be corrected. So, what example we have taken today, that if we consider an engine and if we try to perturb the ignition timing, then certainly ignition timing torque curve will be changed, and then if we perturb the ignition timing, engine speed will change, right. So, ignition time torque curve is inferred from the response of the engine speed. This way what we can do, we can find the ignition timing for a particular operating condition, right. So, and then stored, and this way we can find the ignition timing for a particular operating condition, and we can store that data in the lookup table. Following this, as I have mentioned, we can have control the NOx emission using this exhaust gas recirculation control. If we can have emission control, we also can have airflow control, and we can have airflow ratio control, right. So, this is adaptive based control, that means engine will try to adapt the change or changes. So, engine will try to adapt to the changes of the environments or of the environments, and then engine will try to determine the operating condition from the real time measurements of the engine, and subsequently corrections will be done in the lookup table. So, this is very important. What was done in the memory based control, you know that those data lookup table was there, and from the data that is stored in the lookup table, whether it is readily available from the table, then we can, that ECU will take the data. If it is not readily available, then ECU is also programmed to interpolate, but corresponding or pertaining to this particular type of system, that is adaptive based control, engine the control system has the capability to determine the operating condition from real time measurement. Not only that, and they will correct the lookup table data. So, these are this is all about the memory based control and adaptive control system. Now, we have talked about electronic control system or engine management system. So, what are the input parameters for any control unit? So, let us briefly discuss all these things. So, now we have also mentioned about the rather disadvantages of memory based control. So, when you have talked about adaptive control, then still this particular system has a particular disadvantage, that is the system is very complex. Okay. So, now input to the control system. What are those? One is throttle position sensor, number 2 is mass airflow rate, this is called TPS, this is called MAF, and then number 3 is engine temperature or coolant temperature, this is called CT. Number 4 is engine speed, and crank position. And exhaust gas recirculation, number 5 is exhaust gas recirculation, that is EGR, and number 6 is exhaust gas oxygen, that is EGO, oxygen concentration in exhaust gas. So, these are the input to the control system, and what about the output? So, let me write here output from controllers. So, we will be giving input to the controllers or control system, and we will be getting output from the controllers. Try to recall the block diagram that we have used to discuss about open type and closed type control system. So, what are the output from controllers? One is fuel meter control, number 2 is ignition control, number 3 is ignition timing control, and number 4 is exhaust gas recirculation control. So, these are the basically output from the controllers. So, to summarize our today's discussion, we have talked about 2 different types of control system today, that is memory based control and adaptive control. We have tried to discuss, or we have tried to illustrate the concept or functionality of memory based control with the help of an example, and we have also discussed about the lookup table, As I said you in this lookup table, I forgot to mention that when engine speed or engine load, I should write engine load or speed changes, then ECU will consult to this lookup table. Now, at any particular instant of operation, you know, engine can sense engine speed using crankshaft sensor, and engine also can measure engine load using the throttle valve sensor. Okay. So, you know, measuring or sensing these two control variables, that is, you know, load and speed, engine ECU can consult to the lookup table and try to figure out the current condition, operating condition, and corresponding to that current operating condition, engine can figure out the value of spark timing. That is again another important control variable. And then we have talked about adaptive based control. As such, the difference between these two control system we could discuss today, and then we have discussed about what are the inputs to the control system, and similarly giving some input to the control system, we are, you know, expecting to get some output from the controllers, that is, you know, this is as expected, and we have also listed down output from the controllers. As such, we have seen that there are many sensors: throttle valve, throttle position sensor, you know, air flow rate sensor. So, in our next class we shall be discussing about a few, you know, different types of sensors. So, with this I stop here today. Thank you.